In this video, we're going to talk about the properties of perpendicular lines. First, we're going to talk about congruent linear pairs. Remember that a linear pair is always supplementary, and if they were congruent, it means they're the same measure. So anytime we have a linear pair that is congruent, both angles are going to have to be 90 degrees. In other words, this ray would be perpendicular to line AC. It says here, find the measure of angle CTA. Well, it is a linear pair. This one's marked as 90 degrees. So we know they're supplementary and that the other one would have to be 90 degrees. Measure of angle CTA is equal to 90 degrees. So when two lines or rays or segments are perpendicular, they will create 90-degree angles. And so if I drew some perpendicular lines here, that's going to be 90. We know vertical angles tell me that that one's 90. These are supplementary, so that one's 90. And it's very easy and quick to prove that all four of those are going to be 90-degree angles. And I think most of us knew that from perpendicular lines in the past. Perpendicular transversals. Recall that when two lines intersect, four angles are created. If the two lines are perpendicular, then all four angles are right angles. Basically what I was just saying, that 1, 2, 3, and 4 all here would be perpendicular. Even though only one of them is marked as right angle, we just remember that the others are. When a parallel line is added, then there are 8 angles formed. And if line L is parallel to line M, and N is perpendicular to L, then N would also be perpendicular to M. And that should make sense, but let's go ahead and do a little proof to show that it's true. So we have our statements and our reasons. We're going to say that N is perpendicular to L, and we are told that L is parallel to M. That's our given information. And since N is perpendicular to L, any angle created by those would be 90 degrees or a right angle. So angle 2 is a right angle. The reason I knew that is because the definition of perpendicular. Well, 2 is a right angle. We know that L is parallel to M, so it would be fair to say that angle 6 is a right angle. This is from corresponding angles. And if 6 is a right angle, then that would mean that lines N and M are perpendicular. That's the definition of perpendicular. I think I made that a little shorter than maybe it needs to be, but that was my given information, and there is my conclusion there. Here's a new rule, new theorem. If two lines are parallel and a third line is perpendicular to the one of the parallel lines, it's also perpendicular to the other parallel line. And that's what we just proved to be true. There's also, if two lines are perpendicular to the same line, then they are parallel to each other. So let me draw that out in this little space here. Two lines are perpendicular to the same line. So here's a line. This one's perpendicular to that line, and this one's perpendicular to that line. Then these two are parallel. Here we are asked to determine the measure of angle 1. We see that this box indicates that they are perpendicular. These two lines are perpendicular, which means this is a 90-degree angle. These are parallel, which means this is a 90-degree angle via corresponding angles on parallel lines. And these should be supplementary, so this one would also have to be 90 degrees. So the measure of angle 1 is 90 degrees. So these are very quick. You're pretty much realizing if I have parallel lines and a transversal that's perpendicular, you're going to have 8 right angles. Let's also talk about complementary angles. Recall that complementary angles are when two angles add up to 90 degrees. They can be adjacent or non-adjacent, but if they are adjacent, then their non-common sides would form perpendicular rays. So what you've learned about perpendicular lines can be applied to this situation. So this is 55, that's 35. They're asking for the measure of angle 1. Well, if I add those together, that's 90 degrees. You can do this in lots of different ways, but if this is 90, the vertical angle here, angle 1, that's going to be 90 degrees. Because if this is a 90-degree angle, then all 4 of those are 90 degrees. Same thing over here. Is L perpendicular to M? Explain why or why not. Well, we know that in order for this to be perpendicular, this would be 90 degrees. 67 and 23, I just need to add those together. I get 90. So yes, because their intersection forms a right angle. And that actually concludes the lesson. It's very short today. So we'll do some more examples, more review. If you need anything, let me know.